Good day, Doc Flores. So today we will be solving our given task for our midterm and finals exam. I hope you would understand and like my video. Solve each system of equation. The equation is the following. Number one, it's 2x plus 2y plus 2z is equal to negative 16. Negative 2x is equals to 10. X plus 5y plus 2z is equal to 10. So we will solve the system of equation by elimination. Elimination is adding three equation to derive a the answer of three equations. So if we would combine, that would be combine first, like adding normal numbers. We should start from the right side to the left side. So combining all the whole numbers, 10, negative 16, 10, and 10, that would be positive 4. 2z plus 2z, that's 4z, and also 2y plus 5 is equal to 7y. And combining 2x, negative 2x, and x, that's only x. So our final equation will be x plus 7y plus 4z is equal to 4. Number 2, we have here negative 2x plus 2y. Oh, sorry. It's negative 2x plus y minus 2z is equal to negative 6. 4x is equal to negative 24. Negative x minus 4y minus z is equals to 15. So our answers will be x, negative 3y, negative 32 is equal to negative 15. Solve each system by graphing, find the vertices. Equation is 4x minus 3y less than or equal to 37. So for us to simply determine the vertices, we need to rearrange this equation into a slope-intercept form. So all terms shall be transposed to the right side, not including the y. So we have here negative 3y is less than or equal to negative 4x plus 37. So we need to divide both sides by negative 3. So that's negative 3y over 3 less than or equal to negative 4x plus 37 over 3. So we have here y is equal to negative 4x over 3 plus 37 over 3. So we could no longer simplify at 37 over 3. So simply our slope would be negative 4 over 3. And our y-intercept form, y-intercept or our constant or the b is 37 over 3. Solve for the unknown. So we have here number 7, logarithm of v base 7 is equal to 4. So to solve for the unknown, we need to know the following, that the base is the whole number and the answer, or 4, is the exponent if we would extract that one. So our base will be raised to the power of 4 to solve for v. So that would be v is equal to 7 to the power of 4. So v is 2401. So that would be logarithm of 7, logarithm of 4 base 7 is 2401. So next is logarithm of r, logarithm of 5 base r is 1024. So our to solve for r, so we would raise r to the fifth is equal to 1024. R is equals to fifth root of 1024. R is equal to 4. So if we would have the final equation. So r is 4. Logarithm of 5 base 4 is 1024. And lastly, logarithm of n base 5 is 625. So here we would have 5 raised to the power of n is equal to 625. So we would think of a number that we would raise the base to derive or to arrive the answer of 625. So the best or the number or the suitable exponent that could raise the base to its final number is 4. So that's 5 raised to the power of 4 is equals to 625, and it's equal because 5 times 5, that's 25, times 5, it's 125, times 5, that's 625. So our r is 5, so that's logarithm of 5 base, it's logarithm of 4 base 5 is 625. Next is solve for the unknown. Number 11, that's 4 raised to the power of 6x minus 9 is equals to 1 over 64. So we would need to have a value, substitute to x to derive the same values or to fulfill the equation. So the value that we could substitute to x is 1. So that's 4 raised to the power of 6 times 1 equals 9. And it would be 4 raised to the power of 6 minus 9 is equal to 1 over 64. That would be 4 raised to the power of 3 is equal to 1 over 64. So the ruling for exponent, so we need to have a positive value or positive integers. So we would transpose negative 3. So how do we transpose to that? So we need to convert it into a fraction. So that would be 1 over 4 cube is equal to 164. So in that way, we would derive or arrive to a positive answer or a whole number. So that would be 1 over 64 is equal to 1 over 64, because 4 times 4 is 16 times 4, that would be 64. So 1 over 64 is equal to 1 over 64.